how to determine which conic. Let's talk through if you're given that expanded form where you have to complete the square. It's really helpful if you know which conic it's going to work out to be, so you know what to expect as you are working through the steps of completing the square and that sort of thing. When we learn these section by section, we always know, which type of conic we're dealing with before we even get started. But, of course, on a test, it's all going to be blended together. So how do we determine which conic? So let me begin with the circle. That was the first one we learned. So here's an example. This is actually, we did this example back in 11.1. X squared plus y squared plus 6x plus 10y minus 2 equals 0. So we're not going to work all the way through it again, obviously. How could we tell just right from the start that this is a circle? We would know immediately that it's a circle. And well, I've got it highlighted there because it begins with x squared plus y squared. That means when we complete the square, we're going to get a circle. Let me go a little bit further and we'll look at, okay, well then what is it? X squared plus y squared. Let's compare that with the ellipse. Let's chat about the ellipse next. The ellipse, on the other hand, this is a problem we saw in the ellipse section. 25x squared plus 4y squared minus 300x plus 56y plus 996 equals 0. You notice for both of these, I only look at the x squared and the y squared parts. Ignore the rest. Just focus completely on the x squared and the y squared. So what's different about the ellipse compared to the circle? Well, there are numbers in front. There are coefficients on x squared and y squared, where in the circle there are not. If there are not coefficients on either one of them, or I guess technically you'd say the coefficient is 1, but there's no numbers written there. If all you have is x squared plus y squared, circle. As soon as you put numbers there, now it's like elongating that circle, right? So there's like a ratio between the horizontal width and the vertical width sort of thing. So I've made some notes here. It has coefficients on x squared and y squared. Truth is, it would only need a coefficient on one of them to be an ellipse. It doesn't need it on both. If it just has a coefficient on either one, then that's an ellipse. Also, you are adding. So I note that. Why do we need to pay attention to the fact that we're adding? Well, because in the hyperbola, you'll be subtracting. So we did, actually, I think I just made this one up myself. So we didn't see this example. I just came up with this one because I wanted, okay, anyway, doesn't matter why. So 4x squared minus 49 y squared plus 8x minus 192 equals 0. Again, ignore everything except just focus completely on the x squared and the y squared. There are coefficients, so we know it's not a circle, and we're subtracting, so I know it's a hyperbola, where if there are coefficients and we're adding, it's an ellipse. Okay. And then I think I gave one more example. This is the one that we did in that last problem. Negative 16x squared plus 9y squared minus 160x plus 72y minus 400 equals 0. We have the coefficients on x squared and y squared. It's not subtracting, but that's a negative. So it's really not so much that you're subtracting. It's that one is positive and one is negative. One is positive, one is negative. Doesn't matter which one's negative. If one of them is negative, then you know you've got a hyperbola. If they are both positive, then you know you've got an ellipse. And here the circle, both are positive, but there aren't the coefficients. Okay. Lastly, there's the parabola. The parabola is really very different from the others, so I'll just show you all I got here. We did these two examples back in the parabola section. Y equals x squared minus 2x plus 5, and x equals negative 3y squared minus 6y minus 1. Well, these look very different from the rest, and there's my note. I mean, the thing is, you could be presented these with terms on any side in any sort of a way. This is usually how they're presented. But again, if you focus on the squares, then you notice, okay, so I'm looking at the square, but only x is squared, and here only y is squared. I don't see an x squared. You know, it's just the one. If only one of them has a square, you know it's a parabola. Then, of course, you need to identify, is it opening maybe up versus down or left versus right? If it's x squared, then that's the typical one. That's, you know, the up or down variety, because that's a function. If it's the y that's being squared, that's the right or left variety. But really what we're getting at here is just identifying it as a parabola in the first place. Okay, go check out that handout where you walk through a bunch of them, you identify which conic it is, and if you want to really go for it, go and write them all in the standard form, identifying the different parts I'm looking for. The answer key is there as well, as you can see. Good luck with that. Check out the homework, and see you guys in the live meeting. That's our last section.